Hi everybody and welcome. Today we're going to be taking a look at some practice support examples for our 1.2 guided practice assignment. As always, we're going to be taking a look at very similar questions to what you're going to be working on your practice, just with slightly different numbers or a slightly different context. As always, fair warning, Winnie is sound asleep in my lap, so if you hear dogs snoring, that is probably what it is. So we're going to start off by taking a look at our two-way frequency table. So we are looking at a sample of students that we asked about whether or not they have a set bedtime and whether or not they have a set curfew. So two different questions, and we're showing these two different pieces of information on the same table. So the first thing that we want to do is take a look and see, do we have totals here? So if we take a look, we actually don't. So the first thing that we want to do is add in some total columns. So we'll do totals here and totals here. So start off with the total number of students with a bedtime. We'll do 21 and 3 together. That'll give us 24. Total students without a bedtime, 4 and 12 together. That'll give us 16. So if we add these two together, on the bottom, the total number of students should give us 40. Always want to check our work though, do it the second way with our columns. So let's do our curfew students. So 21 and 4 students have a curfew. So that gets us 25. And then without a curfew, that's 3 and 12 together, which gets us 15. So checking our work, 25 and 15 do add up to 40. So it looks like we do have a total of 40 students surveyed here. So I believe one of the questions, maybe the first table, has one of the total columns missing. So the thing that you need to do is just add up straight across or add up straight up and down, and that will help you find the totals in your frequency table. The second type of question that we're going to see are probability questions. And these ones, excuse me, basically take a look at the probability of a certain population. So we're not looking at everybody, just a certain subset of your population. So for our first one, given that you do have a bedtime, so when we see given next to that, that's going to tell us that's our whole. So given that we do have a bedtime, we want to find the probability that we have a curfew. So that's the part. So setting up part over whole, we identified that bedtime is the whole. So if we take a look at our chart here, I'm going to erase some of this highlighting. We are looking for the whole of bedtime. So here's bedtime, and here is the total bedtime. So that is the whole of bedtime. So this is the only information that we're looking at in what's circled. So the part has to come inside of what's circled. It has to be inside of that whole. So here, the part that we're looking for is curfew. So if we find curfew, cross-reference it across, we're looking at 21. So given you have a bedtime, 21 out of 24 people, or almost every single person, has a curfew. We take a look at that as a percent, 21 divided by 24, so 88% is what that rounds to. That makes sense. If you have a bedtime, it logically follows that you probably have a curfew. It'd be weird to have one without the other. So let's take a look at our second question here, and a very common thing that we're going to see is things done backwards. So if you're asked for given one way, they might ask you to flip it around and do it the second way. So now, given you have a curfew, so there's our new whole, they're asking to find the probability that you also have a bedtime, which is our part. Sorry, Winnie's making so much noise. So the whole is having a curfew. So let's find curfew, and that's our whole. So looking at this as part over whole, the whole here is 25. And then the part is within this, what's highlighted in blue, we're just looking for bedtime. So taking a peek here, we can see just bedtime in there gets us 21. Winnie's got all the squeaks today. Okay, so if we take a look, it looks similar, but it's not quite the same answer. The top one was 21 out of 24. The bottom one is 21 out of 25. So if we take a look at 21 over 25, this one's actually going to be 84% probability. So 21 divided by 25 gets you 0.84. So they're close. They're a few percent off of each other. Like I said, very similar, obviously related, but in this case, different answers. And almost every single time you're going to see a different answer. So the key to today is identifying what is the whole. And you're only working within the framework of what is your whole. So that word given is telling us that we have some conditions on our probability. Hopefully this helps. This should be a pretty good guide for the different types of questions you'll see on the assignment today. And Winnie and I say thanks for watching.